Where is the absolute maximum for f of x is equal to 5 divided by the quantity x squared plus 1 on the interval from -2 to +3? Well, let's first start off by rewriting f of x, because we could rewrite f of x with the denominator raised to the negative first power. X squared plus 1 raised to the negative first power. This will make finding the derivative a little bit easier. So let's actually find the derivative using the chain rule. So we still have the 5 that's there, but then we bring the -1 down. We keep what is inside of the parentheses the same, x squared plus 1, raise it to the negative second power, and then we have to take the derivative of what is inside. And the derivative of what's inside the parentheses is 2x. And then if we simplify this, we will have 5 times -1 times positive 2x, so that's negative 10x, all over x squared plus 1 raised to the second power. And now if we set this equal to 0, we can find our critical values. Well, the denominator can actually never equal 0, so we don't have to worry about that undefined case. Now we could have negative 10x be equal to 0, and x values where that would occur is at x equals 0. All right, so now let's actually draw our sign chart. We have 0. Just remember we're beginning at -2, so if you wanted, you could put -2 here with the bracket to signify where it begins, and you could put +3 with a bracket on the other side to where it ends on the right hand side, to make sure that we select values that are in between there. Since they're really close to 0, we could do -1 and +1, and they're both contained in this interval. So now let's substitute -1 into our derivative function. So -1 times -10 will give us +10, and then in the denominator, -1 squared plus 1 will give us 2 squared. That's going to be 4. That's a positive value also. So we have an increasing, our function's increasing when it's between -2 and 0. And then if we substitute 1 in there, we will have -10 times 1, that's -10, divided by 1 squared is 1, plus 1 is 2, 2 squared is 4, that's positive. Negative divided by a positive is going to be a negative. All right, so we do have increasing to decreasing. So we have a local max at 0, and then if we substitute 0 into our original function, we'll have 0 plus 1 is 1 in the denominator. 5 divided by 1 is 5. So we have a local max at 0, 5. Now let's test our endpoints to see if they give us any other function values. So f of -2 will have 5 divided by -2 squared is 4 plus 1 is 5. So 5 divided by 5 is 1. So -2, 1. That's still not higher than 0, 5. Now let's try our other endpoint, f of 3. That's going to be 3 squared is 9. 9 plus 1 is 10. So we'll have 5 divided by 10, which is 1/2. So we have the point 3, 1/2. That is also not greater than 0, 5. So therefore our local max at 0, 5 is also our absolute maximum, making our answer choice here C.